Question 31. Which statement is correct for the value of E of standard hydrogen electrode? So at 100 kilopascal pressure and 298 Kelvin, we assume the E value for hydrogen electrode is 0. So is used as a reference. It was determined experimentally, no. It depends on the temperature, no, because it's just used as a reference. And option C, it was arbitrarily set. So yes, C is the correct answer. Question 32. Which of these functional groups are present in a given compound? So careful with this question, because in IB chemistry, functional group and class of compound are two different things. So let's start working. So what we have here is class is carboxylic acid and the functional group is carboxyl. So carboxyl. Then we have NH2 here. So the class is amine and the functional group is amino. And then we have carboxamide here, amido. And then we have ester here. And then finally we have phenyl. So let's start reading the statements. So option A, carboxyl, yes. Secondary amino. No, this is a primary amine because nitrogen is attached to 2 hydrogen or nitrogen is directly attached to 1 carbon. So A is not the answer. B, carboxyl, secondary amino, and ester. No, again, we're looking for primary amino. So ether, primary amino, and secondary amino. We don't have ether. We have ester. So D, ester, primary amino, and carboxyl. So D is the correct answer. Question 33. What is the IUPAC name of this compound? So let's look for the longest chain. That's the first thing we'll be doing. So 1, 2, 3, 4, 5. So 5 carbon is the longest chain. So I'm going to circle this. Okay. Start numbering the end that gives the least number to the functional group. So 1, 2, 3, 4, and then 5. So at position 2 we have methyl, and at position 3 we have methyl, and we have aldehyde as a functional group, so they ends at Al. We can get rid of C and D straight away because they are butanol. So that leaves us between A and B. B is not correct because it says 2,3 methyl, but we're looking for 2,3 dimethyl. So A is the correct answer. Question 34. Which of the following compounds can react with acidified potassium dichromate to give acid? So we're looking for primary alcohol or aldehyde. So let's look at option A. So option A is a secondary alcohol because a carbon which is attached to OH has 1 hydrogen, or that carbon is attached to 2 other carbons. So that is secondary, hence no. B is a ketone. So no. If we look at C, let's display C. So we have CH3, we have CH2, and then we have that carbon tied to hydrogen. On the other side is attached to CH2OH and is attached to CH2CH3. Okay, so C is a primary alcohol. As we can see, this carbon which is directly attached to OH has 2 hydrogen, or this carbon is attached to 1 other carbon directly. So C is the correct answer. We were looking for a primary alcohol. Question 35. How many optical isomers exist for ascorbic acid? So in order to answer this question, we need to work out how many chiral carbons there are there. And a chiral carbon is a carbon which is attached to 4 different groups. This carbon seems chiral because it's tied to OH on one side, hydrogen on the other side, and whole of this group on the other side, 3 and then 4, yeah. And this carbon here seems to be chiral carbon as well, because it's tied to 1, 2, 3, and there is a hydrogen there, 4. So there are 2 chiral carbons, so 2 chiral centers or carbons. Hence, there will be 4 isomers, optical isomers. So B is the correct answer. Question 36, 2-bromo-2-methylbutane reacts with warm solution of sodium hydroxide to form an alcohol. So this is an example of nucleophilic substitution reactions. Nucleophilic substitution reactions, they can be SN1 or SN2. So primary haloalkanes, they undergoes SN2, and tertiary halogenoalkanes, they undergoes SN1, unimolecular. So let's work out what type of halogenoalkane is given. If we look at this carbon, so that carbon which is tied to Br is directly tied to 1, 2, and 3 alkyl groups, R, R, and R. So hence this is a tertiary haloalkane, and tertiary haloalkane, they undergoes SN1. Nucleophilic substitution, unimolecular. So let's narrow down the choices. So A is gone and T is gone. Then we left with B and C. And the first step in SN1 is formation of carbocation. There's only one species involved. So the rate expression, we're looking for only halogenoalkane. B is the correct answer. So we can see rate is equal to K and molar concentration of tertiary halogenoalkane. Question 37, which of the following compounds would give an optically active compound on reacting with lithium aluminum hydride? So this reaction is used to convert aldehyde back into primary alcohols and ketones back into secondary alcohols. Option A, we have propanol, and when propanol react with LiAlH4, it will convert back into propanol. So we'll have CH3, CH2, CH2OH. Butanone will convert back into secondary alcohol. So let me draw the structure of butanone. C double bond O, CH3, CH2, and CH3. So when this react with lithium aluminum hydride, we will end up with CH3, CHOH, CH2, CH3, and we have a chiral center here. This carbon is a chiral carbon, is tied to 4 different groups, 1, 2, 3, and 4. So hence C is the correct answer. Question 38. Which statements are correct about the molecular ion M+ in a mass spectrum? So statement 1. The M+ is not always the peak with the highest intensity in the mass spectrum, which is correct. Number 2. The M+ is always the most stable fragment formed during electron bombardment. No. Is the heaviest. It's not the most stable. It needs to break down into smaller fragments. Number 3, the MZ ratio of M+ ion peak gives the relative molecular mass of the molecule. So that is correct. So let's go through the options. A, 1 and 2, no. We're looking for 1 and 3. So B is the correct answer, 1 and 3. Question 39. Which compound gives this proton NMR spectrum? So we can see there are 3 peaks, hence we're looking for 3 proton environment. Okay, so let's look at compound A. So we have 1, 2, and 3 proton environment. Okay, let's move to compound B. So we have 1, these 2 protons, they are equivalent, so 2, 3, 4, and 5 proton environment. Move to C, we have 1, these 2 methyl groups. So 3 protons each, they are equivalent. So 2 and 2. 2 proton environment. Let's look option D. So we have 1, 1, 1, all 3 methyl groups, all these protons, they are equivalent. So then we have a proton with OH. So we have 2 proton environment. We're looking for 3 proton environment. So compound A got 3 proton environment, hence option A is the correct answer. Question 40. A student performs an investigation to determine the content of ethanoic acid in vinegar samples using non-standardized sodium hydroxide. So non-standardized sodium hydroxide solution. Which type of error will occur and how will this affect the quality of the data? So this will be something to do with the method. So we're looking for systematic error. Let's remove C and D because it says random error. We're looking for systematic error and there will be low accuracy. So hence A is the correct answer.